So, welcome to our lesson today, which is surface area of cylinders and cones. So, I'm just going to get started with this. Now, the first thing I'm going to show us is a little GIF. I'm going to make this big so we can see it. Because the hardest part of this is understanding what the surface area is. So, if I've got this cylinder here, what happens is you open up everything that's just around it. And you've got a circle on the top and the circle on the bottom. So you've got this rectangle, which is the curved part, plus these two circles. Now, I'm just going to snap back to try and show you here. Where's my mouse gone? I'm just going to snap back here to try and show you how this works. So the thing that we need to know with this is the fact that if I've got, this isn't very good here, if I've got a circle like this, if I've got a cylinder, okay, this part here is the same as the circumference of a circle. Really, really hard to see that sometimes. So here, this part here of a cylinder, here's my cylinder, okay, there it is there. And that top bit there, this ring here, is the same as the circumference of a circle. Let me show you what I mean with this. I'm just going to draw a little picture. It might be easier to see if you draw it. So I've got my cylinder here. Here's my cylinder. Like so. And I think everybody understands that it folds out. So you've got a circle on the top, a circle on the bottom, and you've got this band here. Not really poorly. A band here, which is this rectangle like so. Okay? So we know the radius of this is the same as the radius here, like so. That radius there. We know the radius of this bottom one is the same as the radius down here. Okay? And what we're looking at here is the we're looking at this part here. This is the bit that we're looking at. And what we're looking at here with this one is the fact that we have this here is the same as the circumference of this circle here. It's that band that folds around, okay? So this band which folds around is the same as this circumference here. So when we're doing this here, we know the circumference of a circle. We've looked at that before. So this is the circumference of a circle, which is the same as this band here. And this is equal to 2 pi r, or it could be seen as 2 pi d in that case. Okay, this length here is the same as 2 pi r, which is the circumference of a circle. And this here is going to be the height of our cylinder, which is this part here. So we've got it in 3 parts: the circle at the top, the circle at the bottom, and then we've got this part here, which is the length of that circumference, which is the width of that rectangle, and then we've got the height there. So we've got 3 parts: a circle, a rectangle with the circumference and the height, and then we've got a circle at the bottom. So I've explained that now. Let's move on to a question, okay? So here we've got a curved surface area, which is equal to pi d, or 2 pi r in this case. Might as well deal with it in pi, in terms of r, times by the height. So the curved surface area is 2 pi r times by the height here. 2 pi r, which is the circumference of this circle, times by the height. Because we know that the area of a rectangle is length times width, which in this case is 2 pi r h. Okay, so that there is the area of this rectangle. The area of the top one here is equal to pi r squared. The area of this bottom one is equal to pi r squared. So when we do the total surface area of these, it's the top and bottom of these, which is 2 lots of this. So the surface area is equal to 2 pi r squared plus the area of this rectangle, which is 2 pi r h. Now this here, you can just substitute into that, but it is difficult to remember. So the thing we need to think about with this is the fact that this length here is the same as our circumference of the circle. Okay, let's have a little go at a question. So we've got 2 questions here. I'll make them big. Remember to get these down in your notes. Remember the best way to learn maths and the only way to learn maths is to do it. Okay, so let's make this big for you. So here we've got 2 cylinders, sorry. And we're going to have a look at this first one. Now, I always think that it's worth, with these, I always think that it's worth drawing them out in terms of the surface area. So let's have a go at both of these then. So let's draw our first one out. This is example 1. So we've got here oval at the top, and we've got our cylinder here. We've got this length here, which is 3 centimetres, and we've got here our height, which is 10 centimetres. So I always think it's worth, for these, drawing out what the net would be of this. So the net is this rectangle in the middle and 2 circles on the top. We know that the radius is equal to pi 3. We know the height of this is 10, so straight away we can say that this is 10. Now the thing that we need to work out, I'll write down what the 2 formulas are we're going to be using. So we use the area formula, which is pi r squared. But we also need the circumference formula, which is 2 pi r or pi d. I'm going to use 2 pi r just because I have here. So remember, the circumference is the distance around a circle, and we know this distance around the circle here is the same as this length here. This here folds onto this, okay? So this length here is this 2 pi r. So let's start subbing all these in. So it's going to be, remember, r is this 3, r is this 3. So this one here is equal to 2 pi times by r, which is 3 in this case. And the area of the top and bottom in this case is going to be equal to pi times by 3 squared. And the area of this top one is pi times by 3 squared. Again, you can substitute straight into the formula. I prefer to understand this and to know where it's come from. So let's write down the rectangle here, which is equal to this width, which is 2 pi times 3, times by the height of the rectangle, which is 10. So let's get that into our calculator. 2 shift pi times 3 times by 10, which in this case is equal to 60 pi. Area this is the units of centimetres squared. And the circles, let's just do one circle and I'll double it in a second because there's 2. So the circle is equal to pi times by 3 squared. 3 squared is equal to 9. That's going to be 9 pi centimetres squared. Okay, there's 2 of these and the rectangle, so it's going to be 9 pi plus 9 pi plus the 60 pi. We can do it all in terms of pi. If we want, 9 shift pi plus 9 shift pi plus 60 shift pi. I mean, we could probably do that on our heads, which is equal to 78 pi centimetres squared. Okay, so that's our first one done there. Let's just check that. 78 pi, they've rounded it. We can round that if you want. So there, 245.04 centimetres squared. like so. Brilliant. So, this question is done. Make sure this is down in your notes. We'll have a look at the next one, which is a little bit trickier. The reason it's a little bit trickier is because it's in terms of x. Okay, we're not going to let that scare us though. So here, example 2. So with example 2, it's worth noting it is in terms of x, but also they don't give us our radius here. They only give us the diameter of this, which in this case is 6x. And the height of this is 5x. So the first thing I'm going to do is write down what the radius of this is. So the radius is going to be half of that, which is 3x. The diameter, if I need to know it, is 6x. I'm going to draw out my net. Radius sent to the edge. Radius sent to the edge. I know the radius of this I said was 3x. I know the radius of this is 3x. I know this height here is 5x. And this here is the circumference of this circle. And we know that the formula, area is equal to pi r squared. Circumference is equal to pi times d, or 2 pi r. Worth noting that this formula comes from the fact that we know that the radius is twice as long as the diameter. So this one here, pi times by d, which is 6x. We could do 2 times by this, which is 6x anyway. So it's going to be 6x pi. That's the length of this here, because it's the same as the circumference. Pi times d, d is 6x, 6x pi. So then we've got the, let's do the rectangle first, which is equal to 5x times by 6x pi. 5x times by 6x pi, which is equal to 5 times by 6 is 30. X times by x is x squared. So that's going to be 30x squared pi. Now let's do the circle. We know the formula for the circle is equal to pi r squared. Be careful when you're squaring r. You've got to be super careful because we've got to square all of this radius. So this is the area of the circle, which is equal to pi times by 3x. Make sure it's in brackets. All squared like so. 3x all squared means 3x times by 3x, which is equal to 9x squared times by pi. So this, remember, is centimetres squared. This is centimetres squared. Remember, there's 2 of these. Okay, so the final little part is the circle plus the rectangle. So it's going to be 9x squared pi plus 30x squared pi plus 9x squared pi. Now, if I've got 9x squared pi's plus 30x squared pi's plus another 9x squared pi's, because they're all x squared pi, we can just add them like they would be like a normal number. So 9 plus 30 is 39, plus another 9 is 48. It's 48x squared pi centimetres squared. Now that one is tough because it's in terms of x squared. Get that one down for now. The ones we're going to focus on are the ones like the question before. 48x squared pi. It is tough, that one. Now, I think I am just going to do one more of these because I want to make sure that you understand it. I'm just going to pick one to do. So let's do example 3. Here we've got a cylinder. I'm going to say the diameter is equal to 10 centimetres. The vertical height here is equal to, let's say, 12 centimetres. Find the surface area. So I'm going to say pause now and have a go at that yourself. I'm going to, hopefully you've unpaused it, hopefully you've had a go at yourself. I'm going to show you how to do this one. So let's draw it out first of all. We've got our rectangle in the middle. We've got a circle on top, circle on bottom. Notice with this one here, that's given us the diameter is equal to 10. So that means that the radius is equal to 5. So I can say straight away that this radius is equal to 5 centimetres. And I can say the radius of this one is also 5 centimetres as well. We know that this height here is equal to the 12, which is the same as the height there. And we know that this length here is the same as the circumference of the circle, and the circumference of a circle is equal to pi times by d, or 2 pi r. They're both the same thing. So this length here is going to be equal to pi times by 10, which is 10 pi, or 2 times by pi times by 5, which again is 10 pi. So 2 pi r, or pi times by 10, this is equal to 10 pi. So this is probably the hardest part of this, and understanding that this part here is the circumference of that circle. As soon as you understand that, it becomes easy. So now let's do the rectangle, which is equal to length times by width. So 10 pi times by 12, which is equal to 120 pi centimetres squared. The circle is equal to pi r squared, which is equal to pi times by 5 squared, which in this case is equal to 25 pi centimetres squared. With this one here, we've got two circles on the rectangle, so it's 25 pi plus 25 pi plus 120 pi. So 50 plus 120 pi is equal to 170 pi centimetres squared. Brilliant. So we're going to move on to a different type of question now. Okay. We are going to do some questions at the end, but it's on both of these. So our next example that we're going to have a look at is cones and frustums. Okay. So we already know what the volume of a cone is. We know it's the area of the base times by the height divided by 3. Okay. So we already know what that is. And we did touch upon this, but I don't think we went into very much detail. We talked about the fact that the area of the curved surface, so the curved part of that cone there, the area of this is equal to pi rl. Okay, so pi times r, which is the radius of this cone, times by l. So we're going to have a look at this question on the bottom down here. So, determine the curved surface area of the cone, giving your answer to one decimal place. So it's not asking for the full surface area here. It's only asking for the curved part. We are going to look at the full surface area, including that circle on the bottom in a second. But right now, it's just saying what is the curved surface area. So here, this is example 4, is it? Yes. Example 4. So here we've got our circle at the bottom. We've got our cone like so. It's telling us this L here is equal to 10. And it's telling us our radius there is 6. So really straightforward. It's the curved part that we're looking for. So the area of curved surface is equal to pi times by r, which is 6, times by L, which is 10 in this case. 6 times by 10 is 60, times by pi is equal to 60 pi centimetres squared. Really straightforward. Now we're only finding the curved surface on that one, okay? So let's have a look at one now where we are trying to find the full surface area, okay? So get this one down. This is example 5. Example 5. So we've got our oval at the bottom. We've got a curved part there. It's telling us the height of this is 4. And it's telling us this part here is 3. Okay? So we've got to find out two parts of this. We've got to find out the circle at the bottom and the curved surface area of this. Now notice with this that there's something missing. When we were looking at this one here, okay, when we were looking at this, it gave us, it's this L part here that we need, but we don't have L in this one. We only have the height and the radius of the base. But what do we spot? We can spot here that this is a right angle triangle. Okay, here we've got a right angle triangle. With this is 3, this is 4. So how do I work out this part here? Well, I work out this part here by using Pythagoras, because it's a squared plus b squared is equal to c squared. A squared plus b squared is equal to c squared. So 4 squared plus 3 squared is equal to c squared. So let's do that. 4 squared is 16. Plus 3 squared, which is 9, is equal to c squared. Add those together, we get 25 is equal to c squared. So square root the other side, we're going to end up with the square root of 25 is equal to c. So c is equal to 5 in this case. So we know that this length here, I'll try and do this in a different colour. We know that that L is 5. There we go. So, we've got everything we need now. So the first thing we need to do is find the curved area. And we know that the formula for that, we worked out before. Sorry, I should have clicked back onto this. I need this now, is pi RL. So the curved area is pi RL. Pi times the radius times is 5. So pi times by 3 times by 5. 3 times by 5 is 15 times by 5 is 15 pi centimetres squared. And then we also need that circle on the bottom. So we need the circle here on the bottom, which is equal to pi r squared, which is equal to pi times by 3 squared in this case, which is equal to 9 pi centimetres squared. So we've got that curved part of the cone and the circle on the bottom. We finish this off by adding those together. 15 pi plus 9 pi, which is equal to 24 pi centimetres squared. And that's that question done. Brilliant. So we've done the surface area of a cylinder. We've done the surface area of a cone. So let's have a go at some of these questions now. We'll make this big for you. Pause now and have a go at these. There's 4 there for you to have a go at. I have got 2 harder ones as well. But pause now and have a go at those. Hopefully you've unpaused, so have a go at these two if you're continuing on. If you're getting a little bit stuck on that first one, you know that the radius is 10, the height is 10. You have to use Pythagoras to work out that length there. So this length here. With your radius of 10, height of 10, Pythagoras there. The rectangle here is going to be the circumference of this circle. The width is circumference, the height is 10. And you've also got a circle on the bottom as well. So let's combine both of those. This one here is quite tricky. You've got to work backwards from the volume. If you need some help with that, make sure you watch the volume video. So I'm going to pop the answers up now. There's the answers to the first four. Well done if you got all those right. There's your answers to the next two. Brilliant if you got both of those right. That last one and that second to last one were quite difficult. So thanks for watching this video. Hopefully you have a nice day, and I hope you enjoyed volume of a cylinder and a cone.